Section 1.3, Simple Random Sampling. The objectives for this section: by the end of this lesson, you will be able to obtain a simple random sample. Now, why do we sample? Well, first, let's suppose we want to know what CMC students think about parking on campus. It isn't possible to ask every single student, so instead we try to get a sample of students. One important characteristic that this sample must have is that it must be representative of the entire student body. In other words, we can't have all culinary arts students or all students that just recently graduated from high school. Now, random sampling is the process of using chance to select individuals from a population to be included in the sample. For the results of a survey to be reliable, the characteristics of the individuals in the sample must be representative of the characteristics of the individuals in the population. The key to obtaining a sample representative of a population is to let chance or randomness play a role in dictating which individuals are in the sample rather than convenience. If convenience is used to obtain a sample, the results of the survey are meaningless. Why are the survey results from the sample taken outside Fenway Park not likely to be reliable? Well, that means that the individuals in the sample do not accurately reflect the makeup of the entire population. Why are the results of a survey of students in your statistics class likely to be misleading when trying to determine what proportion of students on your campus work? Well, your class probably does not match the campus breakdown of male-female students, evening day students, or the proportion of freshmen, sophomores, juniors, and seniors. Now, there are effective sampling techniques. We will discuss 4 basic sampling techniques in section 1.4. Simple random sampling, stratified sampling, systematic sampling, and cluster sampling. Okay, now these sampling methods are designed so that any selection biases the surveyor introduced, knowingly or unknowingly, during the selection process are eliminated. In other words, the surveyor does not have a choice as to which individuals are in the study. Now, we will discuss simple random sampling in this section and the remaining 3 types of sampling in the next section. Now, the first type of sampling, called simple random sampling, is the simplest. A sample of size n from a population of size capital N is obtained through simple random sampling if every possible sample of size lowercase n has an equally likely chance of occurring. Now, what we're saying is that the number of individuals in the sample is always less than the number of individuals in the population. Okay, so maybe that didn't sound too simple. Now, essentially, in order to qualify as a simple random sampling process, each sample must be equally likely. You've probably already used this method without even knowing it. Okay, so let's just say here we have 12 people in the population. Okay, so let's suppose you want to select a sample of 4 people from a group of 12 with this image up here. Here are some common ways to select a simple random sample. Well, 1, you're going to write everyone's name on a slip of paper and then draw 2 from a hat. Number 2, you can write all possible sample of size 2 on slips of paper and draw 1 from a hat. Or you can number each individual and use technology to randomly select 2 integers between 1 and 30. Now, practically the first two lost their effectiveness with large groups, so we're going to be focusing on the latter method. So let's take a look here. With our example of a sample size of 4 from a population of 12, we might use technology to select 4 random integers between 1 and 12. Say we would get 2, 5, 8, and 10, our sample would then look like this. So if we use technology and it would then give us 2, 5, 8, and 10, this would be representative of a simple random sample. Okay, so now what we're going to want to do is now we are going to want to take a look at an example. Okay, so we want to be able to illustrate simple random sampling. Okay, now Sophia has 4 tickets to a concert. 6 of her friends, Yolanda, Michael, Kevin, Marissa, Annie, and Katie, have all expressed an interest in going to the concert. Sophie decides to randomly select 3 of her 6 friends to attend the concert. Now for part A, we want to be able to list all possible samples of size n is equal to 3, meaning the sample size has to be 3, from the population of capital N equal to 6 because there's 6 of her friends. Now once an individual is chosen, he or she cannot be chosen again. So what we're going to do is we are going to then let each number represent a given name. So we're going to let 1 represent Yolanda, okay? And then we're going to let 2 represent Michael. We're going to let 3 represent Kevin. We're going to let 4 represent Marissa, okay? And then we're going to let 5 represent Annie. And then we're going to let 6 represent Katie. So now we're going to list all the possible sample sizes of n is equal to 3. So we have 1, and then we're going to start with 2 and then 3. Okay, and then again we're going to go 1 and then 2 and then 4. And then we have 1, 2, and then 5. And we have 1, 2, and then we have 6. Okay? All right, now what we're going to do is then we're going to start out with 1, 3. So if we start with then 1, 3, if we take a look at 1, 3, and then 2, okay, and then if we have 1, 3, and then we can't use 3, so we're going to have to go to 4 because we can't use 3 twice. And then we have 1, 3, and then 5, and then 1, 3, and then 6. Now I want you to take a close look at this scenario here, okay? Is there anything that's been repeated in the first column? Well, if you take a look, 1, 3, and 2 is already listed here, 1, 2, and 3. So we're not going to use that one here, okay? Do we have 1, 3, and 4 in the first column? No. Do we have a 1, 3, and 5? No. And do we have a 1, 3, and 6? And the answer is no. Okay. So now we're going to go ahead and start with 1, 4. So let's go with 1, 4, and then 2. And then 1, 4, and then 3. 1, 4, and then we're not going to use 4 again, so we're going to have to go to 5. And then 1, 4, and then 6. Now again, are any of these repeated? Well, yes. We can see that 1, 4, 2 is already in the first column as 1, 2, and 4. We know that 1, 4, 3 is in the second column as 1, 3, and 4, so we're going to get rid of that. So do we have a 1, 4, 5? No. Do we have a 1, 4, 6? The answer is no. Okay, next. We're now going to start with the value of 1 and then 5. So we have 1, 5, 2, 1, 5, 3, 1, 5, 4. We're not going to use 1, 5, 5, and now it's going to be 1, 5, and then 6. Now, is 1, 5, 2 already repeated? Well, it is in the first column, 1, 2, 5, so we're not going to use that because it's already been used. How about 1, 5, and then 3? Well, 1, 3, 5 in the second column is already being used. Okay, 1, 5, 4 is in the third column. So now we're using 1, 5, and then 6. Okay, so now let's go ahead and try 1, 6. So we got 1, 6, and then 2. 1, 6, and then 3. 1, 6, and then 4. And then 1, 6, and then 5. So again, let's take a look. Is there a 1, 6, 2 that we've already used? Yes, it's in the first column. Is there a 1, 6, 3? Yes, it's the bottom of the second column. Is there a 1, 6, 4? Yes, it's already in the third column. And is there a 1, 6, 5? Yes, it's already in the fourth column. Okay, now we're going to start with 2. So the next number that comes after 2 is 3, and then we're going to go 2, 3, 1. And then we're going to go 2, 3, and then we're not going to use 2, and we're not going to use 3, so we're going to go to 4 because we can't repeat it. And then we have 2, 3, and then 5, and then 2, 3, and then 6. So out of those numbers, is there anything that's been repeated? Well, we can see that 2, 3, 1 was already in the first column at the beginning, so we're going to eliminate that. Is there a 2, 3, 4? No. Is there a 2, 3, 5? No. Is there a 2, 3, 6? And the answer is no. Okay, next, we're now going to go to 2, 4. So we're going to go to 2, 4, and then 1. And then we're not going to use 2, 4. We're not going to use 2 again, so we're going to have to go to 3. And then we're not going to use 4, so it's 2, 4, 5. And then this becomes 2, 4, and then 6. Now, are any of these being repeated? Well, 2, 4, 1 is being repeated, so we're going to have to get rid of that one. 2, 4, 3 is repeated in the previous step, so we're not going to use that one. Okay, 2, 4, 5 hasn't been repeated, and 2, 4, 6 also hasn't been repeated. Okay, now we're going to go ahead and now go to 2, 5. So we have 2, 5, and then 1. We have 2, 5, and then 3. 2, 5, and then 4. We're not going to use 2 and 5 again, so we're going to go to 2, 5, and then 6. So are any of those repeated? Okay, well, is 2, 5, 1 is from the first column. Okay, 2, 5, 3 is in the 1, 2, 3, 4, 5, the sixth column here. So we're not going to use that one. 2, 5, 4 is in the previous column. And so we have 2, 5, 6. Okay, now let's start now with 3. So if we go 3 and then 4 and then 1 and then 3, 4 and then 2. And then we're going to skip 3 and 4, so that's 3, 4, and 5. And then 3, 4, and then 6. So are any of these repeated? Well, we can say that the first one is repeated. We know that the second one is repeated. And then we have 3, 4, 5 and 3, 4, 6. Okay, now let's go to 3, 5. So if we go to 3 and then 5 and then 1, 3, 5 and then 2, 3, 5 and then 4, and then 3, 5 and then 6. So yes, these are repeated. 3, 5 and 1, 3, 5 and 2, 3, 5 and 4, so we have 3, 5 and 6. Okay, now if we decided to go to 4 now, right, so we're going to go 4, we already did 2, 4, we already did, so that means we're going to go 4, 5. So 4, 5, and then 1, 4, 5, and then 2, 4, 5, and then 3, and then 4, 5, and then 6, so we don't have any of those repeated. So 4, 5, and 1 is repeated, 4, 5, and 2 is repeated, and 4, 5, and 3 is repeated, so we have 4, 5, and 6. Okay, next, if we do 5, 4, and then 1, 5, 4, and then 2, 5, 4, and then 3, and 5, 4, and 6. Okay, all of those have been repeated. 5, 4, and 1, 5, 4, and 2, 5, 4, and 3, and 5, 4, and 6. And then if we go to 6, and any of the following, if we use 6, let's say 6, 5, and 1, 6, 5, and 2, 6, 5, and 3, 6, 5, and then 4. And again, all of those are repeated. Okay, so that means we got our summary. So we're going to list all these values in the table. So here are the values in the table. So we have our 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 2, 6, 1, 3, 4, 1, 3, 5, 1, 3, 6, 1, 4, 5, 1, 4, 6, 1, 5, 6, 2, 3, 4, 2, 3, 5, 2, 3, 6, 2, 4, 5, 2, 4, 6, 2, 5, 6, 3, 4, 5, 3, 4, 6, 3, 5, 6, and 4, 5, 6. So these are all the possible samples of size n, which is equal to 3, of this particular population. And so what this means is now we can go ahead and then name all the names that are associated with that. Okay, so here's our list. Okay, so the first one, we have 1, 2, and 3. So if you notice here, we have Yolanda, we have Michael, and then Kevin. And that represents 1, 2, and 3. So there's 1, 2, and 3. So 1, 2, and then 3. And then again, we have 1, 2, and 4. So Yolanda, and then again Michael. Oops, wrong direction here. Okay, we have Yolanda here, and then we have Michael. So Yolanda, and then Michael, and then we have Marissa. Okay, and then likewise, we have 1, which is Yolanda. We have 2, which is Michael, and then we have Annie, which is 5. Okay, and then you can continue on. So again, we have 1, which represents Yolanda. 2, we have Michael. And then we have, let's see here, Katie, which is 6. Okay, and as you can see here, that's how we're listing the names according to the numbers. So that is illustrating a simple random sampling. Okay, so that's one way of doing a simple random sample. Okay, now let's take a look here. Now it says, comment on the likelihood of a sample containing Michael, Kevin, and Marissa. So let's go ahead and see, where is Michael, Kevin, and Marissa? Okay, so we have Michael, Kevin, and Marissa. So where do we have that? Michael, Kevin, and Marissa. So we're looking for Michael, Kevin, and Marissa. And there's Michael, Kevin, and Marissa. And there's no other option other than just that one. So we have 1 that contains Michael, Kevin, and Marissa. Okay, and how many do we have out of the total? Well, if you look here, we have a total of 20 scenarios. So that's going to be 1 out of 20. So there is a 1 in 20 chance that the simple random sample will contain these 3 friends. Okay? All right, now, how do we select the individuals in a simple random sample? Well, typically, each individual in the population is assigned a unique number between 1 and n, where n is the size of the population. Then lowercase n distinct random numbers are selected, where n is the size of the sample. To number the individuals in the population, we need a frame, which is a list of all the individuals within the population. So there's your definition. Your definition is a frame again. And a frame is a list of all the individuals within the population. All right, let's take a look at one more example that you can do by hand here. Okay, in this example, this says that we want to obtain a simple random sample. And the accounting firm of a Sinise and Associates has grown. To make sure their clients are still satisfied with the services they are receiving, the company decides to send a survey out to a simple random sample of 5 of its 30 clients. If you look here at table 3 that I'm shaking here, this is table 3, and then we have our 30 clients. And each of the 30 clients has a number associated with it. And we want to find out a simple random sample of 5. Okay, so I want you to first look at what we have here to the left. This is a table. This is a random numbers table. At the top, you have the columns. So the first column here is 8, and that goes all the way down. The second column starts with 9. The third column starts with 3. The fourth column starts with 9. The fifth column starts with 2. Then the next column is 6. And then 7 is 3, starts with all the way to 10, all the way to column 50. So these represent a column. And then over here, this is your row. Row 1, row 2, all the way down to row 20. Okay? So the first thing we want to do is whenever we're doing a table, we're just going to randomly pick a spot. Okay? So what you would do is you take your pencil, close your eyes. Okay? And then what I'm going to do is I'm just going to go ahead and then pick this place right here. Well, this is column 4 and column 5. And column 4 and column 5 have a number of 0, 1. Those are the digits, which represents 1. So what we're going to take a look now, we're going to take this number, this 2-digit number, and compare it to the number 30. Now, is it smaller than 30? Yes. So 0, 1 represents 1, so that's going to be one of our selections. Okay? And then what we're going to do is we're going to then go down to the next 2-digit number right below it, which is 52. Now, is 52 greater than 30? The answer is yes, so we cannot include that number. Then we're going to go down again to the next 2-digit number, which is 07, which represents 7. Now, is 7 less than 30? The answer is yes, so we're going to go ahead and include 7. Okay, now we're going to go ahead and go down again to the next 2-digit number, which is 44. Now 44 is greater than 30, so we cannot include that number. Now we're going to go down again to 46. If we look at the next 2-digit number, 46, that number is also greater than 30, so we're going to cross that one out and not use that. And now we're going to go down to the next number, which is 37. Now is 37 greater than 30? The answer is yes, so we're not going to be able to include that number. Okay, now we're going to move down to the next 2-digit number, which is 26. Now, is 26 less than 30? The answer is yes, so now we're going to go ahead and include 26. Now remember, we're looking for a simple random sample of 5. And right now we have 3, 1, 7, and 26. Now we're going to continue and move down here. So now we're going to move down to the next 2-digit number, which is 11. Is 11 less than 30? The answer is yes, so now we have 11. So now we have a total of 4. Now that we've gotten to the bottom of the table, now we need to come back up to the next column and then look at the next 2 columns, which is 6 and 7. So the next 2 digits are going to be 23. Now is 23 less than 30? The answer is yes, and now we have 23. So now we've hit our max of sample of 5. So that represents our 5 clients. And now we can select our 5 clients. And what are our 5 clients? Well, the 5 clients that we're going to pick are the ones that are associated with the number. So if we take a look at 1 represents ABC Electric. Number 7 represents Dino Jump. 26 represents Travel Zone. 11 represents Fox Studios, and 23 represents Simplex Forms. So now we've selected 5 out of its 30 clients. And that concludes section 1.3.